Today we're gonna explore two types of operation on a Panda data frame. The first one is a group by command, and the second is a pivot table command. Now imagine you have here a data structure like this here. You have here a row and here a row, both in yellow, that belong together, and you want to group this together. So what you will get in the result is something like this. And if you have an n-dimensional array, you can imagine, hey, might be not so trivial to do this operation. If you are a visual type, this was the visual explanation. So, if you are a coding type, welcome to coding. We import our pandas, we import NumPy. We're in the latest version of pandas 1.41. If you want to have a look how our data structure looks, easy. We have 4 candidates in 3 different states, and we have 2 days of voting. So together we have 4 times 2 data rows for 3 different states. Let's have a look at the data frame. Hey, that's great. So here we are now with our data frame. We have our candidate, we have AOC, we have DD, we have JS, and we have R. This is just a simulation. We have day 1, day 2, day 1, day 2 for each of them, and we have Washington, Idaho, and Virginia. Notice that we also have missing data in our Panda data frame, and we have a very small minimum, simply to locate it better a little bit later. So what we do is group by command for all voters on both dates. So what we do is we say, okay, I take my data frame and I say group by, and by is the candidate. Candidate here, this is our column that we group by, and this is what we get. And you see, okay, for each of our 4 candidates, we have now day 1, day 2, day 1, day 2, day 2, day 1 together in all the 3 different states. So the group by command already did something. But if you just say, a second, let's do this with the code, and you just execute this, what you will get that you have a generic data frame group by object. But I just wanted to show you how this object looks like internally. So what you have to do is you have to have an operation, a function in a vector space, and here we do the summation. So what we have here is our data frame. We say group by the 4 candidates, and we want to have the sum. Let's see what comes out of this. Oh yeah, this is exactly what we're looking for. We have our 4 candidates here, and then we have our 3 states, Washington, Idaho, Virginia, and the number of votes in those states. Now, if you look closely, you see that in Idaho, our data type in the Panda data frame is suddenly float. Because, you remember, in the original data, in Idaho, we have a missing value. So what we learn is, if you have a missing value and you have integer values normally, your data type for this particular column, in our case Idaho, switches from integer to float 64. Another presentation is, if you do not like this kind of matrix presentation, but if you say, hey, okay, you just add reset index. If you want to have an array-like presentation, as you can see, this is exactly the same presentation, only that now the candidate is also in our top row, and this is more like a matrix, and this is more like an ND array. Whatever presentation you like, if you want to have a new index for you, this is a very simple way you do the group by, and this is the result you're looking for in our data frame. So let's explore a little bit what we can do with this. What happens if we say, okay, we have the group by the candidate, and then I just want to have Idaho. Well, should be possible. But instead of summation, we do an aggregation over a NumPy sum, and we do some reset index. Just let's try it out if it works. Well, at first, since I said type, it tells me, hey, yeah, you get a data frame. So group by candidate, Idaho, aggregate, I will get a data frame. Why I do another type? I don't know. Let's do it. Let's find out. Again, it's another data frame. Well, so independently, if you do reset the index, it is a data frame. It stays a data frame. And then candidate. Okay, we do it one by one, but you know what? Since we are online, we do not have to stick to the rules. Let's have a look how it looks like. Okay, so perfectly. We have now selected one of the 3 states only, and this is Idaho. We are grouped by our candidate, and we have a function now, an aggregate function, numpy sum. So this is exactly, we have our 4 candidates, and this is the sum of Idaho. Idaho is missing here and in the heading, as you can see, but no problem. We can deal with this a little bit later. What I have here prepared for you, oh yeah. If you do this, that you say, okay, over all, if you just have the group by candidate, and you remember, in our data frame, we have also the column voting day to discriminate between day 1 and day 2. Of course, if you, where are we here? If you sum over everything, if you group by candidate and you have the aggregate function over everything, you have also the sum of voting day. So remember, this is not an integer, but you see what's happening. This it just says for AOC, day 2, day 1, day 2, day 1, day 1, day 2. So be careful. We have here just that a string function operating here when we do the summation. You remember our data field here, original data frame here, says day 2, day 1, 1, this, and this is what is added. Okay, so what I have next? I prepared this one to show you what. Oh yeah, if you want to have now a row-wise summation, you want to have all the votes for each of our 4 candidates, what we do is easy. We have our data frame, then we say group by our candidate, and then we have here, now you can see this is now a list command, the string, the name of our 3 states, Washington, Idaho, Virginia. And what we do is, over this we have an aggregation, and then again, because now we want to have also the sum of the rows, and I specify this here in the second aggregation, you can see axis equal 1 or so. This also, yeah, you can reset the index if you want it or not, and you get the result. What happens if we do not reset the index? Get a nicer presentation. Yes, it also works here. We have a matrix representation. We have here our candidate and the sum over, remember, the list of our 3 voting districts or states or whatever. It's just a simulation. So this is what you get if you want to have also the sums of all the different rows. What else I have here? Reset index. I think this we already had. No? Yeah, this was just to, if you do not do this explicit, then this is what you will get with your day 1, day 2, day 1, day 2. And if we do the forget reset, we still get our days. So, as you can see, yeah, multi-index data frame group by. If we now do a group by, not only by the candidate, but also by the voting day. So now we have, and this is the beauty of Panda, a multi-index Panda data frame group by command. And you say, yes, finally, yeah. But we just do it over one state, Idaho. And we do the aggregation, we do the mean and the numpy sum, and we do some reset index. Okay, here we are. This is the command. So let's have a look at this. Our first index here is candidate, our candidate. And then we have the voting day. Now remember, voting day, we only have either day 1 or day 2. But now we have it sorted. We have AOC, day 1, day 2. DD, day 1, DD, day 2. JS, day 1, day 2, and so we go on. And then you have the content if you want, the mean, and the sum of the votes. Interesting to remember. Look here, we have the nen because the mean operation, if there's some data missing, the result is also missing. If we do the summation, you will see here that the group by command says 0. 0 is not missing data, but you have to distinguish between nan, not a number label, and the actual numerical value. This is a float 64, 0. Be careful. Do not mix this up. So, and again, you know, we like to experiment a little bit. Yes, this is much nicer. This is our matrix visualization. And here you can see candidate is our first index, and then the voting day 1, day 2 here is our second, and this has a much nicer visual representation of our datasheet. Of course, we are not just restricted to mean. If you say, hey, wasn't there something where you told us that there is, a minimum that we should look out for? Yes, here we are. So if you have now here the minimum, it is the same. We have a nan, not a number label, because we have missing data in this. And if you do a group by with missing data, you have to be careful. And I show you a method where this takes care in a much nicer way. And here we are at the pivot table. Now, pivot table does more or less the same for us. Remember what I showed you at the beginning? We have this this representation of some data in a matrix representation, on an array representation, and we wanted what yellow is belongs together. We want to find a representation where the things that belong together are together, and the same you can use here now the command in Python pivot table. So I show you. We have our data frame. It's the same data frame. And then we have now the command, instead of group by, we say now pivot table. And pivot table has now some options in addition to group by, a kind of extended version, but it depends on your data. But let's use it on the same example as I showed you above. Now, our values are our 3 states, Washington, Idaho, and Virginia. Now, the index we have now in a pivot table, and if you are familiar with Excel, you know exactly what I'm talking for. I do here exactly the same. Now I know why I had this here with the multi-indexed group by. We had here the candidate and the voting day. And this is the same we do now with the pivot table. We have now the index, the candidate, and the voting day. So you see, it's a one-to-one relation almost with the group by command. Then we have a function, and again, I use here numpy sum, the summation. This is nice. We have a pop-up. And if you want to take care about the missing values, we have here now with pivot table the option to say fill value equals 0, for example. So all missing value will become 0. So if you do the summation, it's nice to have a 0. If you do some multiplication, it's nice to have a 1 whatsoever. And also you have the option of margins. And you can even give a name to the margin. So if I call it subtotal, and I'll show you in a second. And then you can sort this everything. Gee, this is nice. So let's have a look what we get. And this is what we get. We have, again, our candidate and our voting day. So we have a multi-index representation, if you want. For each of our 4 candidates, we have day 1, day 2. Remember now that we have day 1, day 1, day 1, and day 1 thing. So we have sorted data frame. This is nice. And then we have our 3 states, of course. Idaho, Virginia, Washington, and we have the operation here is sum. We have a numpy sum. Yeah, sum, okay. And this is the data. And now you can see here in Idaho, we have a 0 and not a none label anymore. And this minimum with 2 we have here beautifully. So sum over both days. Okay. If we want to have the summation over the days, it is easy. Our index goes just to candidate from candidate and voting day. We have here just candidate. And the result is exactly what we are looking for. For each of our 4 contestants, we have summation of Idaho, Virginia, and Washington. And I told you, you can have here the margins. You can name your margin. I named mine subtotal. And so for each column, you have here the sum of the column. So this ends here our view on the pivot table. We have here a comparison between Groupby command and the pivot table command. I personally like, for my kind of data, the pivot table gives you some additional options you can have, especially if you want to make sure that you have no missing values. This is very nice. Your margin and the sort function here for your new Panda data frame. This is some really nice functionality, and I hope you enjoyed pivot table versus Groupby command for Panda DataFrame. I see you in the next video.